Alright, today we're going to talk about composition of functions, which we started kind of learning about yesterday. So, I have no idea if you can see me right now, but that's okay. Composition of functions. So to compose something means to put two things together. We compose music by adding notes together. We compose pictures by painting two things together, okay? Composition means to compose. So in math, when we compose two functions, what we're doing is when we take a composition is when the answer from one function is plugged into another function. So yesterday you talked about going from this person sitting here, let's go this way and then this way. So we did two different things to our initial point. The same thing happens with compositions. You start with one, you plug it into the first one, and then you plug it into the second one. Okay, it's read as, it looks like this, f of g of x or f of g of x. This little symbol here means composed. So if you read it with a little open circle, it means f composed of g of x, meaning they put them together. Alright, we have two steps for composing functions. First, we evaluate inside the g of x function first. It's not always g of x inside, but whichever one is inside. Then you plug that result into the other function, in this case f of x. Alright, remember that which one is inside and outside might change, so make sure you carefully read the problem and know what's going on. Alright, so let's work an example of this. So say we're given f of x is equal to 2x plus 3 and g of x is equal to x squared. So we want to find f of g of negative 1. So you read these parentheses as of. Okay, so to first start, we want to find g of negative 1. So I'm going to plug negative 1 into here. So I'm going to find g of negative 1, which is equal to negative 1 squared, which is equal to 1. So that means that that's what g of negative 1 is. From there, you replace this entire thing with a 1 because that's what we said it was equal to. So now we're finding f of 1. Well, we know that f is 2 times our x, which is 1, plus 3. 2 times 1 is 2, plus 3 is 5. So our final answer to this is 5. Okay? Same thing for if it's opposite. So we're going to find g of f of 0. Okay? First, we're going to plug in a 0 into f of x. I'm going to find f of 0, and that's equal to 2 times 0 plus 3. 2 times 0 is 0, plus 3 is 3. So then I'm replacing this entire thing on the inside with a 3. So my new thing I'm trying to find is g of 3. Well, g of x is x squared, so we're going to do 3 squared, which is equal to 9. So this entire thing here is equal to 9. So you're taking one thing, plugging it in, evaluating it, which means to solve it, taking that answer, plugging it into the other function. Let's try another example. So it says given f of x is 4 plus x and g of x is equal to x plus 1 squared minus 3, we want to find g of f of a. Now in this case, we don't have a value in here, we don't have a number, we just have a letter. So our answer should end up having a's in it. So first things first, I want to find f of a. Okay? F is 4 plus our x value, which in this case is a. This is your x that you plug into the equation. So that's what we have. So remember, then you cross this part out and you put g of 4 plus a. That's the next thing we want to find. So I'm going to say g of 4 plus a is equal to, and all you're doing is replacing all the x's in the equation with that expression. So I still have a parentheses. I'm going to do double parentheses, 4 plus a for my x plus 1 squared minus 3. Now in this case, because there's a variable in the problem, our final answer will just have a variable. So really you're just going to combine terms just to simplify it down. So you can do 4 plus 1 is 5. So I have 5 plus a squared minus 3 equals, well, we started with g of f of a. Okay? I could multiply that out and FOIL it and simplify it some more, but there's really no point in doing that, so this would just be my final answer. Okay? You do want to simplify the 4 and the 1. Let's try a third example. So say we have f of x is equal to the square root of x plus 3 minus 7, and g of x is equal to 2x minus 4. We're going to find f composed of g of x minus 3. So So if you need to rewrite it with parentheses, which I normally do because I get confused with the composed sign, it would be that. So first things first, we're going to find this. So g of x minus 3 is equal to, we're using this equation, 2 times x minus 3 minus 4. So g of x minus 3 is equal to 2x minus 6, I distribute to both things, minus 4, which is 2x, this we have a plus and a negative, minus 10. Okay, so that's g of x of minus 3. So now I'm going to take this, replace this whole thing with 2x minus 10. So now I'm finding f of 2x minus 10. And now I'm using this equation. So I have the square root of 2x minus 10. Remember, even when you're doing equations like this, you still use parentheses to denote that this is one thing, plus 3, minus 7 is on the outside. So within the square root, I need to combine like terms. Well, these two things are the only thing that will combine. So my final answer, which is f of g of x minus 3, is equal to the square root of 2x, negative 10 plus 3 is minus 7, then minus 7. I can't combine this with anything because it's not underneath the square root. Okay, so that's a little bit about composition of functions. It's a little bit like a puzzle. You have to figure out, I'm plugging one thing in, then plugging it in again. Once you get used to it, it's pretty simple and you kind of get the hang of it, hopefully. We're going to practice this in class tomorrow, but make sure you took good notes and make sure that if you did it, you rewatched the video. Okay? And good time to stop because my computer's freaking out. Alright, have a good night.